There are two different methods for creating tasks within Behavior Designer. The first method uses GameObjects, and then the second method uses entities. In this video, we are going to go over the GameObject method. The GameObject method will probably be your first choice for creating tasks because it has an API that is very similar to the MonoBehavior API. In general, the GameObject method will work very well, except if you have, I don't know, maybe some computationally heavy task logic, or for example, you want thousands or tens of thousands or hundreds of thousands of agents on the screen and you really need to use the ECS system. But for the vast majority of the use cases, the GameObject method should work very well and be very familiar to you. So let's go ahead and get started, and I have a new project created with a pretty empty scene that doesn't do anything right now, but we are going to add some logic to it. I've created two different tasks. There's this move towards destination task, and then there's this has entered trigger task, and we are going to fill in both of those tasks. You can see by looking at this inspector, there's absolutely no code at all, so let's go ahead and change that. But before we do that, I want to describe what we are actually going to want to do. So we want this agent that is represented in the green capsule to move towards this sphere, this orange sphere, and then that will be step one. And then step two will be when the agent enters a trigger, we want them to stop seeking or stop moving towards the destination of the sphere. So let's go ahead and open up your editor, and now I'm going to start on the move towards task. The very first thing that we want to do is define the task name, and that's move towards destination. And this move towards destination is of type action, and you'll notice right now we are getting an error because there's no definition for the action class. And we can fix that by including the Behavior Designer Runtime Task Actions namespace. So we are good to go now. If I were to save this and then open it up in Behavior Designer, we would be able to reference it and add this task. This is the bare minimum that is needed. But right now it obviously doesn't do anything. So let's go ahead and add a little bit more to it. First thing that we want to add is the destination that we're going to move towards. So to do that, I'm going to use the shared variable system, and you'll notice that the Graph Designer Runtime Variables namespace was automatically imported or included, and that brings in this shared variable class. And then the Unity Engine namespace was also included for this GameObject reference. So now let's go ahead and fill out some of the task logic. So let's override the onUpdate method, and what this will do is this gets run by Behavior Designer, and we want it to return a status of running for as long as the agent is not at the destination, and then when the agent does arrive at the destination, we want to return a status of success because the agent had ended at the destination. So that is success. So we can do that by first doing a distance check, and we'll do a distance check between the current agent position and then the destination position, and if that's less than some small value, we will return success. Now, if the agent is not within the distance, we want it to move towards the destination, and we can use the vector3 move towards for that. But before we do that, we need to define a move speed. So I'm just going to bring in this other, or add this other shared variable called move speed. And you can see that it is of type float. And then with that, we are able to do this vector3.moveTowards. So it's another simple call of just taking your current position, and then it's moving towards the destination position at this move speed. In this case, we are not doing any pathfinding or anything like that. We are just using vector3.moveTowards, so it's just going to be a linear path towards the destination. The one thing that we now want to change is instead of returning the base on update, we want to return a status of running because the task has not completed yet, and it should return a status of running while the agent is not at the destination. So that's really all it takes in order to create a new basic task. I can go ahead and bring this into Behavior Designer and we can take a look at it, and we'll see that it will hopefully work. All right, so let me go ahead and click on the agent. We're going to add a behavior tree, and then within Behavior Designer, we are going to add this move towards destination task. So move towards destination. So it's right at the top right here. And you can see when I click on this task, we have our two different shared variables here. I'm going to reference the destination and say that we want a move speed of 5. Now when I hit play, we should see this agent move towards the destination. All right, that worked well. So the task remained active. I'll go ahead and play it one more time. But the task remained active for as long as the agent was not at the destination. And then as soon as it got close within the 0.5 units, it had returned a status of success. So right now it's running and then success. So great, that worked well. Let's make this behavior tree a little bit more complicated and say that instead of it arriving within 0.5 units or returning success within 0.5 units, I want it to stop seeking towards the destination or moving towards the destination when the agent enters a trigger. So on the destination, you can see that I have this sphere collider that is set up as a trigger, and when this agent enters this trigger, I want the agent to stop calling move towards. And we can do that by first using the conditional aborts system. And if you have not, or if you're not familiar with conditional aborts, I highly recommend that you watch that video, the conditional aborts video, because it makes things so much easier in order to reevaluate. So let me just go ahead and quickly set up this tree in order to show how to set or to use the conditional abort system for this. So there's that, and then let's add a sequence task. And then with, no, we don't want random sequence, we want regular sequence. So there's sequence, and then we are going to add a new task, but then let's just, let's also add a log statement just to say arrived. Okay, so we are now going to set a lower priority conditional abort. So yeah, if you haven't seen conditional abort video, highly recommend that you watch that. But we now have to fill in this one conditional task, and this conditional task we wanted to return success when the agent has entered the trigger. There is actually a has entered trigger within Behavior Designer itself, but I'm going to kind of recreate a basic version of that, that task. So the first thing is I'm going to open up the has entered trigger, the has entered trigger script, and so that looks good in that it is completely empty. And let's go ahead and start adding to it. The first thing that we want to add is the name of the task, and it is has entered trigger. It is of type conditional because the conditional task returns success or failure based on the game state. And then you can see this opposite of Behavior Designer runtime task conditionals namespace was already included, so that looks good. The big thing that I wanted to mention in this part and why this task is a little bit unique is because of this right here. By default, Behavior Designer will not issue physics callbacks unless you specify or override this bool that says, or this property that says that you should receive the physics callback. In this case, it's receive trigger enter callback. And then with that, it will allow us to override the on trigger enter. Actually, it's a protected override void on trigger enter. So there we go. So now this, because I had included or overrode this property, that's why this this method will be called when the agent enters the trigger? Well, when the agent enters the trigger, we want to set a bool that will just specify that the agent entered the trigger. Because there's only one other game object that has a collider on it, and it is the agent itself, I don't need to do any sort of filtering or anything. I can just say has entered trigger equals true because I know that it will be the agent that entered the trigger. So let me go ahead and override this task status now, and that, or the onUpdate method, and task status is included in the behavior designer runtime task namespace. So with that, we have a basic conditional task that when the agent enters the trigger, it will say true, and then the task will switch from a status of failure to a status of success. So let's go ahead and see if that worked. And let me has entered trigger, so I wanted to use the one without the namespace because that is ours. So now I will go ahead and connect it and hit play, and then we should see it reevaluating, and then as soon as the agent enters the trigger, we should see the task return success, which will then play this log statement that says arrived. And actually, let me get my console up a little bit more so that you can actually see that the log statement will occur. And I don't want to cover that. So there we go. Okay. Now we should be able to see everything. Let's go ahead and hit play. All right, going. Okay, and you can see as soon as the agent got to the edge of the trigger, meaning he entered it, the conditional task returned success, which caused the log statement to fire, and you see the log statement says that the agent arrived. So that worked. So yeah, that's really all it takes in order to create a new task within Behavior Designer using the GameObject method.